Aggregating large entries in the database to perform a count, for example, is a lot of work. The database has to sort through a large number of records, whether it's in an index or in the raw heap table itself. Doing this too often can impact the performance of both your database and your application. Let us discuss why count can be slow and an alternative if you really don't want the actual count, but just you want an estimate. Let's just jump into it. All right, guys, so there are many ways you can execute a count on your database. So I have here a grades table, our famous student grades table. So there is a G, which the grade itself. That's the ID of the students, right? And I think it has like around 60 million rows that I created. So what I'm going to do here is do a select count G from grades where ID between 1,000 and 4,000. Give me the grades of those people, but I just wanted to count. If you execute that, it's so fast right now. Don't pay attention to the speed because I have caching going on. I executed this query many times, but I want to pay attention to the number that come back, 2,900. And the reason this number is a little bit low from comparing to 1,000 and 4,000, which should be around 3,000, because count G will return entries that are not null. And just think about it. I have an index on the ID field. That means the database have used that index to pull the rows in order to count them. So we're on the index, but we asked the database to do a count on G. That means we had to go to the table to check those the value of G, whether it's null or not. So let's do an explain. Let's just add an explain analyze before these puppies. Let's see what happened here. If I do that, let's pay attention to what happened here. We're doing an index scan on Postgres, right? We have returned 3,001 rows because guess what? We're in the index, right? The actual index entries, I don't have any deleted rows, by the way, here. So 3,001 is about right, but the final count has been reduced because we went back to the table to get the value G, because that's what we asked it. We ask, hey, count the value G. And when you do count G here or count any field, the database will filter through the fields and only count the not null values. And I have few nulls there. Okay. So now it uses an index scan. And that tells me that, hey, I scanned the index, but I had to go to the table. It's not an index only scan, right? Let's spice things up and do the same thing here. But I'm going to do a select star this time. And a lot of people have a misconception that count star actually goes to the table and fetch all the fields and count the fields. No, almost no database do this anymore, right? Count star essentially means just count whatever entries you have, right? This will include null values. If you're scanning the index, give me the values, right? And you can see that we got a higher number. So let's take a look at the plan that that Postgres used to do that stuff. What did you use, Postgres? Tell me. If you look at the plan now, look at this. It's an index-only scan, and always index-only scan always trumps, and always it's better than the actual index scan, because I don't really need to go back to the table. Again, don't pay attention to these numbers because I have caches all over the place, right? I just want you to, the most important thing is to understand the plan. Running these numbers don't mean anything right now, because first of all, I'm in a container. I have a large amount of memory, so the database will start caching these pages if I execute them over and over again. But just understand the plan is the most important thing. And you, as a result, the larger the number of rows come back, the more work the database is doing. So 118, index only scan. All right, Jose, what are you trying to do here? Here's what I'm going to do. I'm going to do an update now. I'm going to do an update. Grades, set G equal 20, where ID is between 1,000 and 4,000. So those rows between 1,000 and 4,000, I'm going to slam all of them and update them. Right? Change this. Let's see how the Postgres will freak out now. What will happen? I'm going to execute this count star, and then let's see what will happen. All of a sudden, guys, look, this number jumped again, not by much, but it is significant, the more rows, the more actual real data you have, this will go back. But look at that. It still says index only scan, but look at this. Heap fetches. I want you to pay attention to this. The moment you start seeing heap fetches, that means index only scan. Yeah, we did only scan the index, but we had to go back to the table 6,002 times, right? For these amount of values, right? I'm not sure these are the blocks or the actual rows. I have to go back and check. But we had to go back this amount of time, which is expensive, right? Why? Because we have updated the values. The visibility map told the index scanner that, hey, by the way, yeah, you're scanning the index, and I'm gonna give you only values in the index, which is usually fast, again, if you're not scanning the whole index. But these rows that I'm scanning in the index might have been updated, might have been deleted. So I have to go back to the heap where the actual visibility of the row exists to check if the row is actually deleted. Because when you delete something in Postgres, the index is not immediately marked as deleted. It just adds a new record and just and keeps the old records for MVCC reasons, so multiple concurrency control, so other transaction can see those old tuples. All right. So how do you solve this problem? Very simple. You just vacuum the table. Vacuuming the table will update the visibility map, saying that, by the way, those old rows that you just updated, nobody's reading them. No, there are no running transactions that are reading them. Right? In a production system, there might be, but not now. So if I do now the same query again, so if we do it again, you can see that we got heap fetches 0. All right. And guys, every time I increase that number between 1004, you can see that this is going to get slower and slower and slower. Just to show you that, for example, now it took 1.5 seconds to execute. And then if I increase that number a little bit, you can see, oh, you can feel it. So count is not cheap, right? It was cheap for the 3,000 rows that I'm going to return, but every time you do that, the plan now changed. Says, okay, we're still going to do an index plan, but I'm going to use threading. The database decided to do multiple threads, multiple workers, not necessarily threads, multiple workers to scan that index. So I can give you the results, right? Still, we're good. We didn't do any heap fetches, but it took 6 seconds to return this many rows, right? So every time you increase, that number goes larger, the operation is going to go slower. It's proportional. It's just so proportional. So, all right. So what if I was saying I don't care about the actual row count, right? I don't really care about giving the actual exact value, right? But here's what I want to do. I want you just to give me an estimate. If you do just an explain, right? And let's just format this so it's JSON-y, right? If you do that, without an analyze again, analyze actually execute the query. Explain will not execute the query, but it will estimate it. It will estimate that, hey, I'm going to use the index. I am planning that I might get this much rows back, 2,868, right? So compared to the select count, so it's not an accurate number. It's 200 values up. And a lot of people use this. And I actually got this trick from a blog that I'm going to reference below. Let's remember that the table itself has some statistics to update itself, right? So the Postgres actually, without actually looking at the table, it knows roughly how many rows are on the table, roughly how much rows will come back. Are these actual correct numbers? Absolutely not. But if you're building Instagram or you're building something that count the likes or something like that, this is way better, right? So I can quickly estimate this stuff. And as you update your table, obviously a good idea to do an analyze on your grades table or your table that will update the statistics to the correct numbers. And obviously this operation is going to take a long time. All right, guys, that's it for me today. That was count, and how count is essentially a lot of work for the database. And if you really don't need an actual count, correct number, especially if it's in the millions, why would you show the user 60 million and 320 exact number, right? Almost no one does that, right? Unless yeah, so an estimate always matter. If you're working with fewer rows, you can do an actual count. But if you expect the table to grow, avoid using a select count. Do an estimate with a planner like that. If that works for you, hope that's way more than enough. All right, again, guys, I'm gonna see you in the next one. You guys stay awesome. Goodbye.